Hello, everyone. We are Versatile Stylists, myself, Christian, and Cyrus. Okay. So pretty much for Versatile Stylist, we wanted to create a digital pen that is able to write on any surface, with the main uses for digital note taking and illustration, and pretty much with like these use cases, what motivated our project was accessibility. So we know that for most solutions, it requires having some sort of like tablet or trackpad to go along with it. So we wanted to have all of the sensing and housing done in the pen and be able to connect directly to whatever kind of computer or other devices that you already have. So it makes it very convenient in terms of cost, being a cheap option, and then also in terms of convenience, since you don't have to be looking around a whole bunch of other hardware and things like that.
Yeah, and for our solution, we basically have a custom PCB that uses a optical flow sensor, and the way that works is that it basically uses like a laser to it shines a laser across the surface, and then basically measures like the time it takes to like reflect back, and it basically uses that to keep track of like relative x and y like movement. And we also have an IMU as well that basically is used for like tilting for tilt calculations. And basically what it works is that it basically allows the user to like hold the pen any way they want, more for like comfortability and yeah, just to be more accurate, I guess. So basically, once we have those two pieces of data, the sensor data from the optical flow and then the IMU data, we combine those together, and that basically has creates our like process movement data that we use that gets sent over Bluetooth to the computer. We also have a pressure sensor as well that basically gets used to actually like keep track of like when the user wants to write versus not write. You'll see later in the demo basically, but when you basically hold the sensor, it like allows you to like start writing or like click like basically like click like the mouse. And if you're not holding it, it'll basically won't click. So all the data gets sent over to the PC using Bluetooth Low Energy. And then basically once the computer receives that data, it can basically like look at the data and then like place the pixels onto like our like Pi game application. And they also have like a LiPo battery as well, to make it more portable and like wireless. And it also can be rechargeable as well. So yeah.
And just for a couple of our testing results, so initially we wanted to have the latency, the end-to-end sensor to drawing latency under 80 milliseconds because that's the average amount of time that it takes for a human to see lag. And so we were actually able to get it down to 46 milliseconds between the sensor data and the display refresh rate. And then in terms of drawing accuracy, we were able to get it no more than a 1% error between a vertical CPI count and a 45-degree tilt CPI count. And 45 degrees is the normal angle that people usually write at. And then we were also able to get the housing to about 40 grams. So this is a bit of a trade-off because initially we wanted it to be around 25 to 30 grams, which is what most stylists are around. But just because of the weight and size of some of our microelectronics, we did have to get it up to about 40 grams. And then in terms of battery life, it lasts about 4.5 hours, which is more than enough time for most people to write and draw. And then even when the battery does die, you can plug it up and charge it and still use it as you're charging. So now we're going to transition to a bit of a demo. So right now we've actually been using the Versatile Stylus to click through some of our slides. And so if I go back to this slide, okay. So as you can see, if we go to my Bluetooth settings, see Versatile Stylus right here. So I'm actually using it right now to move. Then now we're going to transition to a little demo for our canvas application, for our custom canvas application. So as you can see, this is our Versatile Stylus canvas application. So it basically shows how you can use the Versatile Stylus to make different shapes. So I'm just going to write something like, "Hi, Mom," right? And so right now I'm pressing the force sensitive resistor, as you can see on my screen. So we're going to move the camera a bit closer. So I'm pressing on the force sensitive resistor, which goes through our MCU and transfers data through BLE 5.4 to our conversion module that we're using Arduino processing for. And then our optical sensor right now is about 1 inch off of the ground. And if you hold it about this high in the air, it technically can track the sensing there, but we cut it off to about 1-2 inches in the air so that your stylus isn't moving while you're just holding it in the air. I'm going to show you the inside of the versatile stylus. So right now we have the microcontroller unit connected to the battery, and that's connected to the optical flow sensor. So that data just gets transferred to the computer. And anything else?
Seems like that's it.
Yeah, and that is versatile stylus. Thank you.
Thank you.
So you can charge it. So you can use it while it's still charging. Draw some lines. And then, once it's fully charged or to whatever charge that you want, you can unplug it and still use it as Bluetooth. Draw a little smiley face.